So, hello everyone. Today I am going to discuss a very interesting FIFO question that was asked to me in my Qualcomm interview. Since I had mentioned an asynchronous FIFO project on my resume, the interviewer asked me, consider a FIFO where the write clock is 100 megahertz and the read clock is 25 megahertz and the writing a burst size of 120 bytes. Burst, you can say it's a word, right? What is the depth of FIFO needed to avoid the loss of data? Initially, we should know like why do we need a FIFO? Imagine a camera. There's a camera. Okay, this is camera, and here we have a computer. Okay, so the camera is producing data faster while the computer is processing it slowly. Okay, so we put a FIFO buffer between them. So we put a FIFO buffer. It's just like a queue. Like the data which enters firstly will get firstly out. That's why it says FIFO. Okay. It's just like a queue. So the camera is producing data faster while the computer is processing it slowly. So we put a FIFO buffer between them. The FIFO acts like a temporary storage box. The camera keeps sending the data into the FIFO and the computer keeps reading data from the FIFO. So now let's come to the interview question. The write clock is 100 megahertz. Write is 100 megahertz and read is 25 megahertz. So how much time one write takes? So one write takes how much time? Time CLKA. CLK is write clock is for write clock, na? CLKA is equals to 1 upon FCLK. FCLK A, which is 1 upon 100 megahertz. So 10 raised to power 6 we can write it. We have to convert it into nanosecond 10 raised to power 9. So we are left with 1000 upon 100. So it's 10 nanosecond. So one write takes 10 nanosecond to write. Second, so one read takes how much time? Time clock B, which is for read clock. 1 upon FCLK B is equals to 1 upon, it was 25 megahertz. So 25 into 10 raised to power 6 into 10 raised to power minus 9. So we are left with 1000 upon 25. 25 ones are 25, 25 was 100, 0. So it is 40 nanosecond. Okay, so this means the writer is 4 times faster than the reader. Okay, so now consider the 120 byte burst, which was 120 byte burst. Okay, now considering the 120 byte burst. So at 100 megahertz, writing 120 byte takes 120 into 10 nanosecond. If one word take 10 nanosecond, then 120 word will take 1200 nanosecond. 120 into 10 nanosecond, which is 1200 nanosecond. So total time it takes to write 120 word is 1200 nanosecond. Since one read take 40 nanosecond, so since one read takes Since one read takes 40 nanosecond, we can calculate how much reads. So 1200 nanosecond is the total time it takes to write nanosecond upon 40 nanosecond. Okay, so we are left with 0.043 is 20 nanosecond. So we are left with 30 reads. It means, like, at a time we are sending 120 words. Okay, but just because our read frequency is lower than the write frequency, it can read only 30 words at a time. Okay, it can read only 30 words at a time. So we need the total data, which total word, right? 120 bytes minus 30 we can read. 30 bytes we can read. Okay, so we are left with 90 bytes or word, whatever, 90 words. Okay, are left. So it means there's a camera, there's a camera, and there's a computer. Here we require a FIFO depth of 90 from 0, 1, 2 till 89, 90 depth. So here we require FIFO depth of 90. FIFO depth is required to avoid the loss of any data. So yeah, thank you.